Before I show you how to complete the square, I just want to introduce you to something called a perfect square expression. So the three expressions you see here on the left are perfect squares. The bracket to be squared only contains an x plus or minus a constant. So what I'll do here is I'll multiply out these brackets just so you can see what they look like in standard form, which we're used to. Okay, so the first one here, we would have x plus 1 multiplied by x plus 1, which is equal to x squared plus x plus 1, or just x squared plus 2x plus 1. The second one here, we'll do the same thing. X minus 3 squared means we multiply x minus 3 by x minus 3. We get x squared minus 3x plus 9, which is x squared minus 6x plus 9. And the last one here, x plus 4 by itself is equal to x squared plus 4x plus 16, which is x squared plus 8x plus 16. So do you notice a pattern here? When we have a 1 in the bracket, we have a 1 at the end of our expression, and double 1 here. If we look at this one, minus 3, we have double minus 3 here in the center, and what do we have at the end? A 9. 9 is minus 3 squared. If we look at the last one, we've got 4 here, we've got double 4 here, and we've got 4 squared at the end. So if I wanted to write this in general form, I could say that x plus a to be squared is equal to x squared plus 2a plus a squared. And we're going to be using this idea here when we go to complete the square of other quadratic functions. Alright, so I think it's time we did an example on how to complete the square. So all the time when we're doing these, I want you to keep in mind that rule we just saw, that if we ever have x squared plus 2 times the number by x plus the number squared, that's the same as x plus the number 2b squared. And we're going to be comparing our function to this in a minute. So let's take our function. F of x is equal to x squared plus 6x minus 7. So let's take a look at the middle term here, 6x. So we're going to compare it to this 2ax here, as we want to try and find a perfect square within this function. So let's say that 2a is equal to 6. That means that our a must be 3. And then the a squared that we want at the end is just 3 squared, which is 9. So if we were to rewrite our function here, we could say that x squared plus 6x, which is just 2 by 3, plus 9 would give us the perfect square. But the problem is we don't have a plus 9 at the end. We have a minus 7. And we can't actually change the function itself. So what do? We say, well, we still have that minus 7 here at the end, because we don't want to mess with that, but we've added an extra 9 here. This is the only thing that we have changed. We've added this 9. So what we have to do then is take away a 9. For the moment, this might look a bit strange why we would do this, but you'll see in a minute why it's really handy. So that means we can take this perfect square here and express it in this form, the x plus a to b squared form, because we know our a is 3. So this portion of the function here is just x plus 3 to b squared. And now what we do is we just add the constants at the end. So we've got minus 9, take away another 7, which gives us minus 16. And now our function is written in perfect square form.